Chapter 8, question 28. You're standing on a large sheet of frictionless ice and holding a large rock. In order to get off the ice, you throw the rock so it has a velocity of 12 meters per second relative to the earth at an angle of 35 degrees above the horizontal. If your mass is 70 kilograms and the rock's mass is 3 kilograms, what is your speed after you throw the rock? So we start off with our own mass, 70 kilograms. The mass of the rock is 3 kilograms. The velocity of the rock is 12 meters per second. That's at an angle above 35 degrees, at 35 degrees, and we want to know our own velocity. So to start, we will solve the x component of the velocity of the rock, which equals to, so Vx equals 12 meters per second times cosine of the angle it was thrown at, which is 35. And that gives us 9.83 meters per second. From there, we will use conservation of momentum. So the initial momentum is equal to the final momentum, which equals 0. So the initial momentum is just the mass of yourself, which is 70, times the initial velocity, which is 0, plus the mass of the rock, also times 0, so that just gives us 0. And the final momentum is equal to the mass of yourself, 70 kilograms, times the velocity, plus the mass of the rock, 3 kilograms, times its x component velocity, which is 9.83. And we want to solve for velocity. So velocity equals, subtracting 3, this equals 0. So subtract 3.98, or 3 times 9.83 to the other side. You get 3 times 9.83. And you divide it by your mass. And that gives you a velocity of negative 0.42 meters per second.